So well done getting this far in Battle Tank. Now look, I'm completely aware that throughout the entire section, I've been telling you that we're going to fix the suspension on the tank. And the good news is we are. The challenge is it's a little bit harder than we thought. Sam, what is involved in fixing this tank's suspension, specifically the popping off the terrain issue?
Yeah, so what's happening is that so far we've been going with quite a not really very physical model of having a slab being dragged across terrain.
Just like this.
Just like this. And so there's going to be some issues there. If you imagine pulling a 40-ton slab across some terrain, and even the slightest little hiccup in the terrain is going to make it spring up.
Yeah, and
basically.
Probably because of floating point rounding errors in the representation of the terrain height or something like that, we're getting those conditions where the physics engine thinks there's a collision at the boundary between this bit of terrain and this bit of the terrain where there's a little tiny step, and boom, stuff happens.
Exactly, and we'll go into more detail on this in the coming content. But the way we're going to fix this is by adding in what is typical in most vehicles, is to have a suspension, which is exactly for damping these kinds of forces. How do suspensions typically work, Ben?
Well, typically you've got a damping and a rebound. So basically you've got a spring with some sort of resistance to it. So one question is how stiff is the spring? And then the other question is how much does it resist speed? So how much does it resist force and how much does it resist speed? That's the damping and the rebound or whatever they call it. But basically the thing you need to know is how much does it resist compression, which depends on the weight of the vehicle, and how much does it resist velocity, which is typically done through oil going through a small hole in a piston, which limits how fast the thing can move. Yeah. So they're the two factors we're going to be tweaking.
Exactly, and we're going to have to figure out how we can represent this in Unreal, and that's quite tricky because there are a few different ways of doing it. Some of them are very advanced and use the physics engine to its fullest potential, which we're not going to go into. But we're going to go into one that does allow you to have a better idea of how the physics engine is working and gives you more tools to use in your games, not just for suspension. So it's a much more general purpose tool, and that's what we're going to teach you.
Absolutely. So Sam has worked really hard to do this for you. Read between the lines. Don't just look at exactly how to solve this physics, but continually think, how can we widen this, and what are we learning about the engine, and what are we learning about basic physics as we do it? And I think you'll get a huge amount out of the coming lectures.
Absolutely. So I look forward to seeing you in those lectures.